Is there anybody here who knows about what do you call mobiles? Like how the storage of mobiles work? So what are the storages we have in mobiles? So when we go to buy an iPhone nowadays, I think it's iPhone 16, right? If you want to go and buy an iPhone 16, the next question, what would they ask you? What is the storage you want? What are the types of storages we have to buy? Have I heard that how many GBs or TBs you want? Have you guys heard about it? Anybody here? Anybody here who knows about storages? Storages of something? Even when I was going to buy my hard drive, yeah, they were asking me what is the storage I want for it. Yeah, what are the types of storages we have? Can we just go and ask for a like? Can I have iPhone 100, iPhone 16 100 GB? Is there anything called 100 GB mobile? No. So what are the types of GBs we have? Anybody knows? Anybody who have like common knowledge about this world? Or everybody is just like the lab rats who are just made up at home for the exam, go to the exam, tick, 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 done, and come home. Anybody who goes out to the world here? What are the types of storages we have? We have 1 GB, then we have 2 GB, and what is the other GB we had? 4 GB. Okay, after that? 8 GB. Then after that? 16. Okay, and then 32. All right. Interesting. So 1 GB, 2 GB, 4 GB, 8 GB, 32, and after that? Okay, 64. Then 128. Yeah, and then 256. Yeah, that's usual. Everybody likes a 256 iPhone back in my days, about 2 or 3 years ago. Not anymore, but yeah. What is the after that? 512. Yeah, and then 1T. Yeah, 1024, and then we have 2048. What are these numbers, Pute? What are these numbers? Anybody can see any number pattern here happening here? You will never ever see like a 7 GB iPhone. You will never see something called a 300 GB iPhone. Yeah, it's always either you buy 256 or you have to buy 512. Why? What is happening here? Pute, these number systems, yeah, these things are 2 to the powers. These things are powers of 2. Yeah, as an example, yeah, remember 1 means a 2 to the power of 0. All right, 2 means just a 1 2 is there. 4 means a 2 times 2, right? 2 to the power of 2. Yeah. Then 8 means 2 to the power of 3. 32 means 2 to the power of 4. 64 means 2 to the power of 5. Yeah. Then this is 2 to the power of 6. Yeah. 2 to the power of 7. Wait. I think I did something wrong. 1, 2. Oh, I forgot to write down 16 GB. Yeah. Before 32 GB, there's 16 GB. Yeah. When iPhone first came out, iPhone, I think 6 or something, not 6. iPhone 3 or something. Yeah. I think my sister or somebody had a 16 GB. Yeah, it was the one of the small, very small like this. Anyway, this is 2 to the power of 7, 2 to the power of 8, 2 to the power of 9, yeah, 2 to the power of 10, yeah. Why put these 2 to the powers? Now, why am I talking about these things? What the hell is happened to sir today, right? Yeah, no, but these are the way we call binary numbers. The powers of 2's. Numbers. Yeah, numbers of the second power. We call it numbers of the second, or 2's powers. Yeah. In binary number system, Pute, now the number system which we use in our day-to-day life, we call it, those are decimal numbers. The number system we use in our day-to-day life, we call it decimal numbers. Yeah. Why? Decimal. What does it mean by decimal? Now, many people think when I say decimal numbers, answer decimal number means the number with the point. No. Decimal means with a deci. Anybody knows what deci means? 10. So our number system which we use in our day-to-day life are made with 10 digits. That's why we call it decimal numbers. The 10 digits are what, Pute? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and those are the numbers. Now, out of these 10 digits, Pute, yeah, all the number system is made. Now, some people say, okay, sir, what about the number 10? No, but the number 10 means a 1 and a 0. 1 and a 0, it's a place value. Decimal numbers have their place values. Those place values helps us to create more other type of numbers. But decimal numbers have only 10 digits, which is 0 to 9. Now, put these binary numbers. Binary numbers got only bi. Bi means what? Yeah. Not something in the LGBTQ or ST community, anything. Bi means what, Pute? 2 digits. Very good, Aditya. Bi means 2. 2 means what? 0 and 1. This number system is made with only zeros and 1. Now, you guys might have watched that movie called Matrix. Have you guys ever watched it? Yeah? Never? Oh. You guys are watching. Okay, let me show you. Their main, what do you call? They don't have anything to do with these binary numbers. But Pute, their main picture has these binary codes in it. Like, it's so funny the way it came out. So many people were thinking, oh, this might be something coding or anything like that. Actually, Pute, coders use binary numbers. Even now, when I was creating my own small, what do you call? Let me quickly grab it for that. Here we go. Yeah. So this picture was a very, very popular one back in my days. Yeah, here we go. So ones and zeros. Yeah. So Pute, the funny thing is this. Yeah. When we even code, this zero means pretty much in even electrical thing. Oh my goodness, I have forgotten many words. Electrical engineering also zero, or even in IT we call it zero means no. 1 means yes. Yeah, or 0 means negative. 1 means positive. Yeah. Now, if you switch on a light, we call it's a 1 state. When you switch off the light, we say it's the no gate. Yeah. So it's something like that, kind of like that. Yeah. So anyway, now what we are going to learn today is how to work with these. How to work with this binary number system. That is what we are going to learn. Yeah. So even in that, what we are going to mainly focus is how to make a decimal number into binary, how to make a binary number into decimal, and how to process the addition, subtraction, multiplication or division. No, sorry, not multiplication and division, only addition and subtraction. So conversions, between each other, and addition and subtraction. That is what we are going to study today. Alrighty, cool. So then, let me tell you all something very important. Now in our day-to-day life, If I say y'all, Hariputa, can you all write down 2050? 2050. I am saying it to write it down in decimal numbers. On those instances, only for this lesson, Pute, at the end you have to write down 10. To represent it's a decimal number. 10 means decimal number. Yeah, if it is a binary number, yeah, an example I'm giving. Yeah, an example, if it is a binary number, it will look like 101001110, something like that. And if I say 2, that means it's a binary number. Do you guys get it, Pute? When we write a binary number, we write the digits ones and zeros only and write a 2 at the back. So everybody knows I'm talking about a binary number. Yeah. If I'm writing a decimal number, I will just write down the normal digit and write a 10 at the back. Some teachers are very picky about decimal numbers, also writing 10 at the back under this lesson. But some teachers knows, come on, you don't have to write a 10 at the back, because end of the day, if you don't write anything, in default we know that it is a 10. Yeah. But again, if your teacher is a little bit of an old person or a person who has a mentor of an old person, definitely they will be checking whether you write the 10 at the back or not. So to be in the safe side, remember, Pute, under this lesson, whenever you are writing even a binary decimal number, make sure that you write down it. But now, what I want you to do is quickly, yeah, write these numbers down, and if you can also, Pute, memorize it on the way. That will be very helpful. But up to one extent, you don't have to memorize spot on. It's just double in no. Yeah, it's not that bad or that hard. Yeah, quickly write down the first 12 binary numbers. Yeah, and then memorize it, Pute, because this will be helpful for us to do the conversions. Quickly write it down and try to remember it. Yeah, I will give you all maybe a little bit of time to write it down and get used to it. I will give you about 2 to 3 minutes, Pute, and after that, let's start do the conversions. I mean, this lesson is very easy. Don't worry. Alrighty, Pute. I hope that you guys are done. Yep. Now, Pute, first thing, let's write down how to make a binary number back into a decimal number. How to convert a binary number into decimal. Now, binary numbers, I told you all that it's a number which is made only using ones and zeros, right? Yep. So that's how it is. Now, when I call out your name, Pute, you need to tell me whether you like to use 0 or 1. Yeah, so we are going to make a humongous binary number and we are going to convert it into a decimal. Yeah. And yeah, we need to definitely start the first digit with 1. If not, it will be a number. No? Yeah, 1. Then Sahansa, Pute, 0 or 1. Okay, and then only Pute, 1. Okay, Khaled. What the heck happened to him? 0. Okay, and then Aditya, Pute? 0. Alright, Hansa, Pute? 1. Okay, Chenruti, Pute?
1.
Okay, Natanila, Pute? 1 or 0, Pute? No? Not a no, Pute. Either 1 or 0. Quickly tell me whether 1 or 0. Oh, just say me if you like me to use a 0 or a 1. That's it. A digit 0 or a digit 1? Anything? Okay, 0. Okay, Ashwin, Pute? 1. Okay. And then Anika Pute?
1.
Okay. And then Dulip Puta? 0. Alrighty. Let me write it down with a little bit of space. Normally we don't keep that much of spaces. Right? And then at the back of it, we definitely put a write down 2. Now in IT, we write it like just a letter, like a digit 2 like this. But unfortunately in mathematics, you have to write down 2. Okay, so keep that in your mind. I know that in IT, you just have to write it like digits. Now Bhute, I told you all binary numbers means place values of whom? Binary numbers means place values of 2's. Yeah, so you need to decode this place value. Yeah, decode this thing under the powers of 2, Pute. Yeah, under the powers of 2. So let me write down how to go under the powers of 2. I will need a little bit of space here because this is a humongous number. Normally these things will go only like 4 or 5 lines. Yeah. Okay. Alright, here we go. What are the numbers we have here? 0, going from back to front, 1, 1, 0, 1, 1, 0, 0, 1, 0, 1. Those are the numbers we wrote down. Yep. Times by, 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 times by. Okay, Pute, tell me. Let's start with the powers of 2's. 2 to the power of 0, how much is that? 1. 2 to the power of 1 is a 2. 2 to the power of 3, that's a, 2 to the power of 2 is a 4. 2 to the power of 3, 8. 2 to the power of 4, 16. Power of 5 is a 32. That means there's a 132 here. 64, there's no 64. That's a 0 here. Yeah, 1 to 8, there are no 1 to 8s. Yeah, 2, 5, 6, there's a 1. Yeah, 5, 12, there's no 5 12s. And then 1, 0, 2, 4, there is a 1 of it. Alright, Putta. So now what we need to do is write down the digits here. Was there any 1? No. 1 was a 0. So it's a 0. Nobody. No 1s were there. Any 2s were there? Yes. 1, 2 was there. Any 4s? Yes, a 4 was there. Yeah. 8s? No. 16? Yes. Can you say 8? No means we all know 0 times by 8. That's a 0. Then 1. Any 1s? Yes. 32. Any 64s? No. Any 1 to 8s? No. Any 2 5 6s? Yes. Any 5 12s? No. Any 124s? Yeah. 1024s? Yes. And all now we need to do is add those digits up. We have our decimal number. Yeah. So 2 plus 6, 4 is a 6. 6 plus 16 is a 22. 22 with a 32, that's a 52. Yeah. So that's a 52. 52 with a 256. Yeah. 256. That's a 308. 308 with a 1024. That's going to be a 2, 3, 3, 1. Yeah. 10. So it will be a 1332 10. 1332. Yeah, decimal 10. Yeah. Normally, if you are a normal person would just write 1332. But in mathematics, yeah, for this lesson only, as I said, this lesson is the only lesson which this binary number coding, binary numbers are there in the whole entire syllabus. Yeah, and they really want us to write 10 at the back, which I don't really appreciate whoever wrote this book, like the note. But anyway, we had to write it, so we need to write it. Yeah. Right down to there. Did you guys understand what just happened here? Anybody who didn't understand what the hell I did? Anybody wants me to go through it again? So this is all about going with the powers of 2's. Yeah. This is a 1. This is a 2. 2. There was a 2. There was a 4. There was no 8s. 16, yes. There was a 16. 32, yes. Yeah. 64, no. 128, no. 256, yes. 512, no. 1024, yes. And then you just add them up. Yeah. Quickly write that down. And once you are done, can you guys quickly let me check. Khalid Putar. Maybe I might have missed something there. They're missing. Yeah. Sorry, Pute. Yeah. This is 22 with a 32. That's not a 52. It's a 54. So if that is a 54, this will be a how much Pute? 310. If that is a 310, this will be a how much? 310. No? If it is so, this is a 1334. Sorry, I did a small mistake with my additions. 1334. My mistake. Thank you, Pata. I missed the 2. Yeah. 22 plus 32. I wrote as 52 by mistake. Everybody good with it? Did you guys understand how I did it? Yeah. Okay. Quickly write that down and let's do one more question together. And after that, I will let you all do some questions by yourselves. Then Putta, let's do a question together. An easy one, definitely. Let's say that I got a binary number such that it looks like 10011. Yeah, the 2 at the back. You're still writing. Sorry. There we go. We'll quickly write that down, Putta. And others, if you know how to do this question, get it done. If you don't know, don't worry. I'm going to go through it with you. Just hang tight. Yeah. You know how to do this question, convert it into a decimal. Please do it so. Let's have a look now, Pute. Yep. Okay, there are some answers I got so far. Khaled Putaya answer is correct. Chenuke Putaya answer is correct. Dulil Putaya answer is correct. Let's have a look anyway. Only Putaya a little wrong. Let's check it. Aditya correct. Here we go. Yeah. 2. Yeah. So remember Putaya always the first digit is 2 to the power of 0. Yeah. That means it's a 1. Yeah. The next one, next place value is 2 to the power of 1. The next place value is 2 to the power of 2, which is a 4. Yeah. 2 to the power of 2. Yeah. The next place value is 2 to the power of 3. And the next place, which is a 8. And the next place value is 2 to the power of 4. Let's write down. I think only what happened to you is you started from 2 to the power of 1, didn't you? Yeah, that's the reason. Yep. So here we go. 2 to the power of 0 means how much, Pute? 2 to the power of 0 means a 1. So 1 times by 1, that's a 1. Yeah. 1 times by 2 to the power of 1 means a 2. 1 times by 2, that's a 2. 2 is answer correct, Pute. 0 times by 2 to the power of 2, which is a 4, right? So let me write down these things. This is a 1, this is a 2, this is a 4, this is a 8, and this is a 16, right? 2 to the power of 4 means 16. Yeah. So then it's easy for me. 0 times by 4, that's a 0. 0 times by 8, that's a 0. 1 times by 16, that's a 16. Now we just need to add them all up. 1 plus 2 plus 6, that's a 9. 1 with nothing is just a 1. There we go. It's a 1910. Yeah. 19 base 10. Or a decimal 19. All goody, everybody? Alrighty. if you guys all are good, all make sense, can you guys quickly do these 3 questions for me? And then after that, today we will go and learn how to make a decimal into a, that means if they give you 1910, how to go backwards. Okay. Quickly work it out. If there's anybody who doesn't understand any part of this thing, let me know, Putha. I'm more than happy to go through it again. Alrighty, I think some of you are almost done. Yeah, let's have a look at the first answer, Putha. And Nathaniel, Putha, I hope that you're alright. Yeah. Alrighty. Anyway, let's move on. 1 0 1 1 0 1 2. Okay. So the first one is 1 times by 1. The next one is 0 times by 2. The next one is 1 times by 4, and the next one is 1 times by 8. Yeah, next one is 0 times 16, and the last but not the least is 1 times by 32. We double check whether I wrote down the numbers properly. 1, 2, 4, 8, 16, 22. Yep. So this will be a 1 and a 0 and a 4 and an 8 and a 0 and a 32. Yep. And that will give me a total value of 1 and a 8, that is a 9. 9 with a 32 is a 41. 41 with a 4, 45. So the first answer will be 45. All goody? Yeah. Then the next one. Next one is a 1 1 1 1 2. Yeah. So the first one means 1 times by 1. The second one means 1 times by 2. The next one means 1 times by 4. And the last one means 1 times by 8. Tick, 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 tick. 1 and a 2 and a 4 and a 8, because everybody is there. Every place value is there. And then that's going to be a 15 day. 15. Everyone good with it? Most of you have got that answer correct. Actually, anybody who sent me the answers, they have got it correct. Ashwin got the first one a little here and there. Even Anika got the first one a little here and there. Apart from that, others. Anipute, don't forget that the first digit or the first place value is 2 to the power of 0, which is a 1. Keep that in your mind always. Many times, even I forget it sometimes. That's normal, but it should not be normal in the exam. Yeah. So always remember 2 to the power of 0 is the first place value, or the first place value for decimals. 2 to the power of 0, which is a 1. Then put the last one, which I gave you all to do, yeah, which is going to be 1 times by 1, then 1 times by 2, then 0 times by 4, and then 0 times by 8, and then 1 times by 16, and then 0 times by 32, and then 1 times by 64. Alright. Now let's do the additions here. 1, 2, 0, 0, 16, 0, 64. Put a 64 and a 16, that's a 80. 80 with a 2, 82. With another one, 83. 83, 10 will be the answer. 83 base of 10. 83 base of 10. All good, everybody? So far, so good, Pata? No problems? Then for that, let's write down converting a decimal into a binary number. Now, Pute, there is a traditional way which we used to use, as well as there's a much easy way. First, let me teach you all the traditional way so you all will understand what the hell is happening here. And after that, I will teach you all what is the easy way of doing it. The easy way of doing it is much faster. Yeah. But anyway, let me teach you how this traditional way and the easy way works. The traditional method is this. Even if you don't understand it, don't bother much because there's a much more easy way than this to do. Okay. Let's say that we got a 33410 and we wanted to convert it into a binary. First Pute. Now what you need to do is start to write down place values. Keep a box for each place value. Yeah, starting from 1, but don't go above 234. So the first one is 2 to the power of 0, which is a 1. Yeah, still it's less than. 2 to the power of 1 is still less than. 4 is less than 234. Yeah, 2 to the power of 2. Can 2 to the power of 3 stand here? Yes. That is a 8. 2 to the power of 4, that's a 16. 2 to the power of 5, that's a 32. 2 to the power of 6, that's how much? 64. 2 to the power of 7, 128. 2 to the power of 8, that's a 256. That's a little too much. So we will have spaces only up to 7 digits. Do you guys understand that, Pute? Everybody got the idea there? Yeah. Don't go above the value you have. 2 to the power of 7, which is a 128 is the largest we can go because 2 to the power of 8 is a 256. 256 is more than 234 we have here. So don't go above that. Got it? And now, Pute, what you need to do is start to do takeaways. We have a 234. Can I take a 2 to the power of 7, which is a 128 out of it? Yes, of course, I can take a 128 out of it. A 128 can be taken out of this number, right? And once I take away, now I'm going to take away a 128. So once I take away a 128, I will be left over with a 106. Now 2 to the, let me write down, this is a Z, this is a 1, this is a 2, 4, 6, 8, 2, 4, 8, 16, 32, 64 and a 128, right? Can I take a 64 out of 106, Pute? Yes, of course I can. I can take a 64 out of 106. And once I take a 64 out of 106, what will I be left over with? I will be left over with a 42. Can I take a 32 out of 42? Yes, I can take a 32. Yeah. Once I take a 32, Pute, I'm left over with a 10. Can I then take a 16 out of this 10? No. So that's a 0. Can I take a 8 out of a 10? Yes, I can take a 1 8 out of a 10. And once I take a 1 8 out of a 10, there will be only 2 left over. Can I take a 4 out of a 2? No. Can I take a 2 out of a 2? Yes, I can take a 2 out of a 2. Then 0 left. Then can I take a 1 out of this 0? No. There we have. The binary number is 1 1 1 0 1 0 1 0. Does that make sense, Pute? How I did it? Everybody got the idea there? Yeah, kinda. Okay. Quickly write this thing down, Puta, and give your best try to convert this 9810 into a binary number. Give your best try to convert it into a binary number. And after that, I will teach you all a little bit of a different strategy or an easy method to do it. Hansapathe, didn't you understand it?
No, sir.
Okay. Can you remember the 2 to the powers, Hansa? Yeah, okay. Let me do a question with you while others are doing it. Tell me any number you like, Hansa. Anything. Any big number. Whatever the number comes to your mind.
12.
Okay, Ambo, 12 is very big, right? Tell me a big number than that. Maybe a 3-digit number?
102.
102. Okay, that's at least a little bit better. 102, 10. Alright. Now let's say that we wanted to make it into a decimal. Now Pute, quickly tell me 2 to the powers. Tell me all the 2 to the powers you know, starting from 1. So after 1, what is it?
2.
2. And after 2?
3.
Eh? 2 to the powers. 2 to the power of 0 is a 1. 2 to the power of 1 is a 2. Then 4. And after that?
6.
Pute, double it. Yeah? 1 times by 2 is a 2. 2 times by 2 is a 4. 4 times by 2 is a?
8.
Then 8 times by 2?
16.
16 times 2?
22.
32. 32. Now keep on going like that, but don't go above 102. Alrighty? Okay, let's keep on going like that. What is 2 to the power of now 32 times 2?
64.
Okay, and then 64 double it?
128.
128. But 128 is a little bit more than 102, right? So don't write that. Do you get that answer? So far, so good?
Yes.
Yeah. And now, Putha, what we are going to do is, I'll just like to put some boxes so I will remember it. This is the traditional method. This is not the way I want you to do it. I will teach you a much more easy method soon. But anyway, let me teach you how the traditional method looks. Now, we will start to do takeaways, Putha. You know how to do subtraction, right? Obviously.
Yes.
Yeah. Okay. From 102, Putha. From 102, the number we have. Yeah. The first place value we have is a 64. Can I take a 64 from 102? Is it possible to do a 64 takeaway from 102? Yeah, right? Because 64 is less than 102. No? Yeah. Now let's do the takeaway. 2 takeaway 4 can't do it. Ask from the neighbor. Neighbor is a 0. Ask from the neighbor. 1 will become a 0. 1 comes here. That 10 will become a 9. 1 comes here. 12 takeaway 4 is a 8. 9 takeaway 6 is a 3. Do you understand, Pudhe? So we can take a 164 out. You get it? If you can do it, you put a 1. If you can't do it, you put a 0. That's it. Okay. Now the next number is a 32. Can I take a 32 out of a 38, Pudhe? The number I have left is now 38 because I took a 64 out. Can I take a 32 out of a 38?
Yes.
Yes. So that's a 1. Let's do a takeaway 32. Okay. What is 38 takeaway 32?
6.
6. Now, Pudhe, tell me, can I take a 16 out of the leftover 6 here? From the 6, can I take a 16?
No.
No. Can I take a 8 out of the 16?
No.
I mean 6. Yeah. Can I take a 4 out of the 6?
Yes.
Yes, I can take a 4 out of the 6. And once I take it out, now I'm left over with a 2. Can I take a 2 out of this 2?
Yes.
Yes. So once I take the 2 out, I'm going to be left over with a 0. Can I take a 1 out of this 0?
No.
No. There we have our number then. The binary number is 1, 1. So we had a 1, 1, 0, 0, 1, 1, 0. 1, 1, 0, 0, 1, 1, 0. And we write a 2 at the back. 1, 1, 0, 0, 1, 1, 0, 2. Got it, Pudhe?
Yes.
Yeah. Now try to do the 32. I mean 98. The answer question which I gave. Everybody good? Okay. Let's check the answer now. Now 98, right? 98, 10. I want it to make it into the place value of 2's. Place values of 2 starts from 2 to the power of 0, which is a 1. 2 to the power of 1, which is a 2. 2 to the power of 2, which is a 4. 2 to the power of 3, which is a 8. Then 2 to the power of 4, which is a 16. 2 to the power of 5, that's a 32. 2 to the power of 6, that's a 64. But 2 to the power of 7 is 128. That's way too much. Alrighty. Then from 98, yeah, can we take a 64 out? Yes. What is left over then? That means 2 to the power of 6. Yeah. Remember, this 2 to the power of 6 means a 64. This is a 32. This is a 16. This is a 8. This is a 4. This is a 2. And this is a 1. 2 to the power of 0 is a 1. So can we take a 64 out? Yes, of course. That will give me a leftover of 34. 34 will be left out. Then can I take a 32 out of 34? Yes, I can. Yeah, what will be left over then? That will be a 2 left over. Yeah, can I take a 16 out of a 2? No. 8 out of a 2? No. 4 out of a 2? No. 2 out of a 2? Yep. I can take a 2 out. Then can I take a 1 out of a 0? No. So what is my answer? 1, 1, 0, 0, 0, 1, 0, 2. By the way, when we read it digit by digit. Yeah, don't try to read it like the answer is 101, 110,010. No. It's 11000 There's 2. All goody, everyone. Then let me teach you all an easy tactic or easy method to get the exact same answer without, I don't know. Some people find this thing easy. Some people find the previous method was more, this method is more, traditional method is more easy than this. It depends. Alright. But definitely knowing this will be helpful. Let me maybe start with this question we need. Yeah, let's check whether we can get the same answer using this easy technique. 234, right? So the easy method, or we call it short division with remainder column method. Short division with remainder column method. So this is how it goes. Yeah. So 234, let's say the same question which I gave you all at the very beginning, 10. Let's say that I wanted to make it into a binary. Yeah. So 234, we will start to, because binary numbers are 2's powers, we will start to divide it by 2. Let me keep a small dotted line here. Normally we don't draw a dotted line, we just draw a dash or something. Yeah. So in this side we will write down if there are any remainders. That's it. Okay. So 234 divided by 2, how much will it be? If there is a remainder, tell me what is the remainder. If there is a no remainder, say me 0. Okay. Maybe Sahansaputa, 234 divided by 2, how much will it be? You guys know how to do divide by 2, right? I suppose you guys are in grade 9. Yeah. How to do divide by 2 here? Sahansaputa, tell me quickly. Something happened to her connection, I think. Maybe Sansa's connection got stuck or something like that. Okay, Aditya Pute, can you tell me 234 divided by 2? How much is that?
117.
117. Remainder?
0.
0. Perfect. Alrighty. Then, Sahansapute, I think your connection got stuck. Can you give me a help with this? 117 divided by 2. I think she got stuck again. Okay. Anybody, quickly tell me, 117 divided by 2. What will it be? 58 with a 1 remainder. Perfect. Now 58 divided by 2, how much is that? We need to keep on going until we have 0 left over. Okay. 29. Remainder? Remainder 0. Okay. Now 29 divided by 2. 14. Remainder?
1.
Remainder 1. Okay. Then 14 divided by 2. 7. Remainder 0. 7 divided by 2. 3. Remainder 1. Okay. Then this 3 divided by 2.
1 remainder 1.
1 remainder 1. Then put a 1 divided by 2.
0 remainder 1.
0 remainder 1. Now you might be wondering, what did we do? Pute, we just got the answer. Yeah? What is the answer? Go from the bottom to up in the remainder column. Go from the bottom to up in the remainder column. That is the binary number. So it's going to be 1, 1, 1, 0, 1, 0, 1, 0. And we write 2 at the back. Alrighty. Does that make sense, everybody? Yeah, 1, 1, 1, 0, 1, 0, 1, 0. Is that the answer we got here? Okay. 1, 1, 1, 0, 1, 0, 1, 0. Perfect. So can you see for that? That is another way of doing it. Okay. Let's do another one. The question which I gave you all before, we do by ourselves 98. Yeah. So if I get a 98, okay. Yeah. And if I want to convert it, what will I do today? I will quickly grab 98 and start to divide by 2. Usually, this is the way we do it. We divide by 2, that's going to be 49, remainder 0. Then we divide it by 2, that's a 20, what? 24, remainder 1. Then divided by 2, that's a 12, remainder 0. Divided by 2, that's a 6, remainder 0. Because it is divisible. If it is divisible, remainder 0, no? Yeah. Then 6 divided by 2, that's a 3, remainder 0. 3 divided by 2, that's a 1, remainder 1. 1 divided by 0, that's a 0, remainder 1. Pute, remember, we need to come until we get a 0 here. Yeah. And now read from the bottom to the top. So that's going to be a 1, 1, 0, 0, 0, 1, 0. Did you guys understand it, Pute? It's much faster, right? This method. Much faster, much easier. So, yep. There we go. Everyone so far so good? Then, Putha, I'll give you all 2 questions from each part which we studied so far to do from your textbook questions, and then we will go to the next chapter. I mean, not next chapter, the next part. Can you all quickly do the conversion of these 2 and quickly do the conversion of these 2? Right? The first one is to make the decimal into binary, and the other one is making the binary into decimal. Quickly work it out and send me as a one message, Pute. Yeah, not it will be very hard to find out which question is whose, which answer is whose, I mean. Alrighty, Putha, let's have a look at the answers here. I hope that you guys have done it. Everybody come here quickly. Okay, so 29. I will use the easy method, then it's easy for me to take my answer quickly. Divided by 2, that's a 14. 14, remainder 1. Divided by 2, 7, remainder 0. Divided by 2, that's a 3, remainder 1. Divided by 2, 1, remainder 1. Divided by 2, 0, remainder 1. Boom, boom. That's going to be 1, 1, 1, 0, 1, 2. Yeah. Next one, 168. Yeah. You can divide it by 2. That's a 84. Remainder 0. Divided by 2. That's a 22. 42. Remainder 0. Divided by 2. 21. Remainder 0. Divided by 2. That's a 10. Remainder 1. Divided by 2, 5, remainder 0. Divided by 2, that's a 2, remainder 1. Divided by 2, 1, remainder 0. Divided by 2, that's a 0, remainder 1. Go upwards. The answer will be, what is it? 1, 0, 1, 0, 1, 0, 0, 0, 2. Got it, everybody? So far, so good, everyone? Then the next one. Yeah. 1, 1, 1, 1, 1. 1, 2, 3, 4, 5. Yeah. 2. We want to make it into a decimal. This means 1 times by 2 to the power of 0, which is a 1. The next one means 1 times by 2. The next one means 1 times by 4. The next one means double the 4, which is a 1 times by 8. The next one means 1 times by 16. Yeah. So that's going to be a 1 and a 2 and a 4 and an 8 and a 16. And if you add them up, 16 plus 4, we know it's a 20. This is a 10 with a 1. 20 with a 10, that's a 30. 30 with a 1 is 31. 31, 10. 31, 10 is the first answer. Got it, everyone? All good? Then the next one, 1, 1, 0, 0, 0, 1, 2. Let's convert it to there. So the first one means 1 times by 1. The next 0 is the power of next 2, which is 2. The next 0 means times by 4. The next 0 will times by 8. The next one will times by 16. And the next one will times by 32. That's going to be a 1 and a 0 and a 0 and a 0 and a 16 and a 32. And that will give us a 9 and a 4. 49, 10. 49, 10 is the answer. Everybody good with that? No problems? Yeah? Alrighty. Now they like this. So, can somebody tell me, what does it mean by decimal numbers? I mean, the binary numbers. Binary numbers means the highest value a binary number can have is how much? What is the highest value a binary number can have? Can someone quickly tell me what is the highest value the binary numbers can have? Anybody knows? In a one place value. Now, highest value in decimal numbers is a 9. After that, once it becomes a 10, that whole 10 will go to the other side as a 1. Can you all remember, like when we were doing normal additions? If you can remember. Yeah. Now let's say that we had a 11 here. What will happen? 9 plus 1 is a 10. So 10 will not give any remainders here. One whole 10 will go to the neighbor. Actually, the reality is this is not a 10. This is like 1 and a 0 means not a 10. It means you don't have any ones places, a 1 whole 10 goes to the neighbor. Why do I say like that? Because we all know in abacus. Abacus is the best thing which helps us to understand how actually number system work. Even though in school we studied, 11 means 1 comes down, 1 goes to the neighbor. No. 11 means a 1 comes down and a 1 whole 10 goes to the neighbor. Yeah. So, as an example, let me show you. Now, remember in binary numbers, the highest value is a 1. Because why? 2 means the next number, not here. This is how binary numbers looks like. Okay, let's do it together. A 1 means just a 1. That means just a 1 like this. All good, everybody? Oh, maybe I might use this. Look how this works, then it will be very helpful for you to understand how binary numbers looks like. Let's say now put it in binary numbers. 1 means a 1. 1 means a 1. And 0 means 0. Obviously, nothing is there means a 0. In binary numbers, put 2. A normal 2 means the whole thing is filled now. Once the whole thing is filled, what do? We take those 2 out. Once the whole thing is filled, what do? We take those 2 out and give a 1 to the neighbor. Can you all remember? Even in an abacus, if it is a 10-digit abacus, once it becomes a 10 here, what we will do with it? We will take those 10 out and give a 1 to the this guy, right? No, this guy, yeah. From here, we will give it to here. One thing, a 10 means we don't keep a 10 like this. We just give a 1 place to the tens place. Yeah, like that. So just like that, even in binary numbers, once it becomes a 2, 1 goes to the neighbor. Yeah. So in binary numbers, remember there, once it becomes a 2, 1 goes to the neighbor. So 2 means a 1, 0. Yeah. Then 3 means, yeah. What does it mean by a 3? A 3 means a 2. Now look here, this is the place value of 1, place value of 2, place value of 4, place value of 8, place value of what? 16 and place value of 32. Now it's easy for you to understand. How to make a 3, Pute? How to make a 3? A 3 can be made by 2 and a 1. 3 means a 1 and a 1. Does that make sense? How to make a 4? A 4 means a 4 can be easily made. What should I do? Just take everybody out here. Okay. Just take everybody out here and give a 1 to the 4th place value. The 4 means how much, Pute? 1, 0, 0. Then a 5. How to make a 5? Can somebody quickly tell me how to make a 5? 4 plus what?
1.
Huh? 4 plus 1. So what will be the binary number of 5? 1, 0, 1. 1, 0, 1. 4 plus 1. Got it? Okay, what is the binary number of 6? Quickly tell me.
4 plus 2.
4 plus 2. Very good. That means what will be the binary number?
1, 1, 0.
1, 1, 0. Then how to make a 7?
1, 1,
1, 1, 1. Then how to make a 8, Pute? 8 will be a, we can take the pins off and give a 1 here. Just 8 by itself. That will be a 1, 0, 0, 0. Yeah, that's it. Does that make sense to you all? How this works? How the abacus of binary numbers work? No problems? Yeah? That means once it becomes a 2, what will happen? Once it becomes a 2, yeah, we don't keep the 2 like that. We make those 2 into a 0 and give a 1 to the neighbor. Yeah? But if it is a 3, what will happen? If there are 3 places, what will happen? Yeah? If there are 3 numbers here, what will happen today? We will take a 1 group of 2 and give a 1 to the neighbor and let that one be as it is. That's a 3. If I want to make a, let's make it easy for us to understand. Let's say that I want to make a 9 hole. Okay. Let's say that I want to make a 9 hole. Is there a way I can grab? Mobile is down. The problem with this thing is it always goes nuts when it catches, because this has a green color, and this thing doesn't like green color because I'm using a green screen. Try to put the green color. Will that help me? No. It doesn't want to focus. Okay, doesn't matter. Yeah. Now let's say like this, Pute. Okay, that's okay. The green color will appear. Don't worry about it. Okay. Let's say that I got a here 1, 2, 3, 4, 5 and a 6. Okay, Pute. How many groups of 2s can I make here? This is a 1 group of 2. I can take that 1 group of 2 and give a 1 to the neighbor. I can take another 1 group of 2 and give a 1 to the neighbor. I can make another group of 2 and give a 1 to the neighbor. Now out of these 3, yeah, I can make a group of 2, give a 1 to the neighbor. Can I make a group of 2 here? No. So let it be. Can I make a group of 2 here? No. So if you make a group of 2, if you can make a group of 2, you give a 1 to the neighbor. Do you guys get the idea? Everybody? Yeah? Okay, let's make another one for easiness. Let's say maybe, let's say that I got maybe a 11. I got 11 digits. Okay. 1 digit, 2 digit is 3, 4, 5, 6, yeah, 7, 8, 9, 10, 11. Yeah, in binary numbers you can have only ones and zeros. Yeah, how many groups of 2's can I make here? In 11, how many groups of 2's can I make?
5.
5, then leftover is a 1, right? So leftover 1 will be left over here. I can make this and put a 5 to the neighbor. 1, 2, 3, 4, 5. Alright. How many groups of 2's can I make out of these 5? 2. I can take a 4 out, that is a 2 groups, and put 2 to the neighbor. 2 groups. Can I make any groups of 2 here? Yes, I can make a 1 group of 2 here. One group of 2 will come out, give a 1 to the neighbor. There we have. So what is it? 11 means a 1, 0, 1, 1. 1, 0, 1, 1 is 11. Did that make sense, everybody? The way we think about it? Is that clear? So in binary numbers, you can't have anything more than 1. If it is anything more than 1, we think about how many groups can I take out of it and give it to the neighbor. If there's more than 1, we take a group and give it to the neighbor. Got it? We always keep on giving to the neighbor until we have only ones and zeros left. All good, everyone? Is that clear? Yeah? Think it like that. Yeah? And can you all quickly create the abacus for maybe number 19? For the number 19. Can you all quickly create an abacus for me? And tell me the binary number of it using only the abacus strategy which I have taught you. Yeah, using the abacus strategy, think about how to make a 19. Yeah. From a 19, how many groups of 2's can you take? Yeah, just draw a little bit of lines here. For now, use a pencil because you need to keep on rubbing it off now. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 numbers are there. Obviously, this is not possible. First, you think about how many groups of 2's can you make. 1 group, 2 group, 3, 4, 5, 6, 7, 8, 9 groups of 2's you can make. That 9 will go to the neighbor. 1, 2, 3, 5, 6, 7, 8, 9, and these numbers will, these dots will cancel out. Okay. Now out of the 9, think about how many groups can you make and give those groups to the neighbor and rub out those circles. Like that, keep on going until you have only ones and zeros left. It's a very soft skill of doing it, but it will be very helpful. Very good, Chinati. That answer is correct. Others also quickly make it, think it like that and do it. This is also what we are trying to do is, yeah. What we are trying to do is, but there we are trying to make this in that. Yeah. Making a decimal into a binary using abacus. Why am I teaching it? For additions and subtractions, we need it. That is. Okay, I'm getting some good answers. Ashwin Putra, that answer is correct. Hansa Putra, think about it again a little bit. You're almost there. Maybe it's a writing problem. Check it again. Dulin Putra, good job. So Hansa Putra, well done. Aditya Putta, well done. Yeah, let's have a look. Now here, how many groups of 2's can I make? 1 group, 2 group, 3 group, 4 group. Out of a 9, we can make groups of 4 groups. Those 4 groups will come here as 4 numbers, and those 4 groups will get out, right? 4 numbers. We can get rid of those 4 groups. Okay, now these 4 groups, how many can I make? How many groups of 2's can I make? 1 group and a 2 group. Any leftover? No. But those 2 groups will come to the neighbor and we can get rid of those groups which we made. Even these 2 groups, we can make a 1 group of 2 and give it to the neighbor. Then what will happen, Pute? No more groups will be there. What is the answer? 1, yeah, 1, 0, 0, 1, 1. Did that make sense, everybody? Yeah. So what does that mean? If you see more than a 2, actually more than a 1, make a group of 2, give to the neighbor. You see more than 1, make as much as groups of 2's and give it to the neighbor. Make as much as groups of 2's and give it to the neighbor. All good? Everybody? So clear? No doubts? Yeah? Alright. Then let's write down addition with binary numbers. Oh, sorry, I have gone more than we are supposed to, right? Sorry for that. Okay, don't worry. Don't write addition with binary numbers. Let's have a break for today. I'm so sorry for holding you guys. I just went down. Yeah, next time, if I'm going more, yeah, in grade 9, it happens a lot. I totally miss my timings. That happens always. Yeah. So, Pute, please tell me if I'm going longer than 10 minutes, sir. Isn't it the time to finish? Yeah. So then it will be very helpful. If not, you guys will be here for another 2 or 3 hours. I don't even know. When I start to teach, sometimes I just go out of time. I just forget the time. Yeah. I'll see you guys next time then. Sorry for holding you guys for 15 minutes. Yeah. Bye bye, Buddha. Have a great week ahead.
Thank you, sir.
Thank you.
Thank you, sir. Bye, sir.
Bye.